What's the outer level of electrons called?
The valence.
The valence electrons are the electrons that are in the outermost shell, right?
Mm-hmm.
So obviously the valence shell is the outermost shell, correct?
Yeah.
All right. How many electrons do most elements want to have in their valence shell?
8.
And what is that called? Does anyone remember?
Like the octave or something?
You're very close. It is the octet rule.
Oh.
What's the one element that doesn't follow the octet rule?
The helium?
Well, there's two, right? Hydrogen and helium, because they're in the first period. They only have one shell, and the outermost shell for that one is filled with 2 electrons. Very good. And so helium is full, and hydrogen is not full. Hydrogen, the reason that hydrogen is so reactive is because it's not full. It needs one more electron. Anyway, so when an element decides that it's going to lose or gain an electron, it becomes an ion. Instead of an atom, it's called an ion. Atoms have no charge. They're neutral, 0. An ion is going to have a positive or a negative charge. Now here we have two separate kinds of ions. We have a cation. Cations are positive. Anions are negative. Okay? When elements or atoms form ions, they join together in what we call an ionic bond. An ionic bond is when you transfer an electron from one atom to the other one. I'm going to show you an example in a minute. But here's a good example. Sodium and chlorine. Sodium has one. Sodium chloride. Sodium has 1 valence electron and chlorine has 7. So the 1 valence electron from sodium travels all the way over to the chlorine, and that creates an ionic bond because they're bonded together and it makes a new compound called sodium chloride, which is table salt. Okay? When compounds form, the compound is completely different in its properties than it was before. Because sodium, I was telling Rachel earlier, sodium is a grayish metal and chlorine is a greenish gas. And they're poisons. But when you combine them, yellow-green, I guess. But when you combine them, you get white crystals that you can eat, which is kind of strange. All right. There's another kind of bond besides ionic bonding, and it's called covalent bonding. Covalent bonding is when electrons are shared, okay? Like, for example, hydrogen forms a lot of covalent bonds because hydrogen does not want to give up its 1 electron, all right? It would be silly of hydrogen to give up its 1 electron because then it wouldn't have any left, but it says, I'm not going to give you mine, but I'll share. So hydrogen ends up sharing. That's how we make water, okay? Because oxygen has, I'll show you some more in a minute, but that's the sharing. This one's sharing, this one is transferring. Okay, then across the periodic table, we have, when we start on the left, do we have more metals, nonmetals, or metalloids?
Metals.
Yes, we start mostly with metals. So these are the ones on the left-hand side of the staircase. Okay, they tend to form ionic bonds. They form they usually make positive ions. Okay. If you notice on the right, we have more whats?
Gases.
Which are they metals?
No.
They're non-metals. So we have non-metals on the left. But if you look, it looks like
aren't non-metals on the right?
Non-metals are on the right, I'm sorry. If you look at it, it looks like there's a staircase. The elements that touch the staircase are not metals or non-metals in many cases. They're what we call metalloids because they have some of the properties of metals and they have some of the properties of non-metals. Okay, and these different kinds form different kinds of bonds. Some of them are more likely to form ionic and some of them are more likely to form covalent bonds. And now, we can predict fairly certainly the ways in which an element will become an ion based on where it is in the periodic table. So group 1, they all have 1 valence electron. So what kind of, and they all want to give it up. Okay, so when they give up that one electron, are they gonna be more positive or more negative?
More positive.
More positive, so what's gonna be their charge?
Positive.
And it's one positive. That's what we call the oxidation number. Everything in group 1 has an oxidation number of 1 positive. Everything in group 2 has 2 valence electrons, 2 positive. Then we skip the whole transition elements because they're funky and they don't follow the rules. They're the rebels of the periodic table. And then we go to 3. They have 3 valence electrons. 3 positive. 4 positive. Then we get to 5. It's easier if you have 5 electrons to do what?
Give
To give 5 or to gain 3?
gain 3.
Gain 3. So then what would that would be your oxidation number? 3 negative. So then negative 2, chlorine negative 1, and then the noble gases are the exception. Do they react at all with anything?
No.
No. Okay. So this you can you can cut out and do later on your own. And now we're gonna talk about bonding a little bit more specifically. Okay. You will be needing these two next.
When's this due?
Monday. Here. So what we're gonna review right now is the bottom. An atom that gains an electron, 1 or more electrons, will have a positive or a negative charge. What do you think? If it gains an electron? Negative charge. You can be filling it in. We're on the bottom of the first page I just gave you. Very good. Thanks, Mason. An atom that loses an electron? Positive. And when the atom gains or loses electrons, it becomes a what? Instead of being an atom, what do we call it? An ion. Good. A positive ion is a
It's a
cation ion. And a negative one is a anion. Okay, so now we're going to look at the back. Atoms will transfer 1 or more blanks in an ionic bond. What do they transfer? Electrons. Very good. And each atom will be left with a what kind of outer shell? We know this is called a valence, but what's going to happen? What's the goal of the ionic bond? Which means the outer shell is full. There you go. Each atom is left with a full outer shell.
But my blank is on the transit.
Huh.
But his.
You guys are looking at the wrong page.
No, we're on.
You're on the back of that one. You're on covalent bonds. We're on ionic bonds. And it says the last one, an ionic bond forms between a blank ion with a positive charge and a blank ion with a negative charge. So, which ion has the positive?
Cat.
Let's review. Cat. And the and with the negative. And we're going to do one now. We're going to do sodium and chlorine. So what we're going to do is we have these little, let's find our sodium and our chlorine. You guys know your element symbols? See if you can help me find a sodium and a chlorine in there.
I found
If you
chlorine.
find a chlorine or a sodium, very good. Cl is chlorine.
Sodium. Wait, I have another chlorine.
Oh, okay. Well, you guys can all have, if we have more than one, we can make more than one.
Yeah.
We're going to combine sodium. You guys can put it closer to you if it's easier.
We have 3.
Oh, okay.
4.
We have more. I'm going to have lots of
I
skittles.
have blank if this is Scrabble.
All right. If it's Scrabble. All right.
I have 2 in it.
So how
feel like
many
I'm playing
valence
bingo.
electrons? Keep your NAs to yourself. How many valence electrons does sodium have? What group is it in? Look,
It'll have like.
so that I don't want to touch them all. Get one. You need one valence electron for your sodium to make your Lewis structure. Oh, because they were in the refrigerator. That's orange. I mean, that's red. Get an orange one so that we match.
I have 2 NA. Let's see if I can make it fair.
You guys are doing it together, so just put it on your one. I'll do mine in the middle. Put your one. I think we start up here with our Lewis structures.
You start. Yeah, you start here.
Okay, so grab one and put it. I'm gonna be able to make the compound. You guys are working together. Now, how many valence electrons here? You can put yours back up. You don't need it right now. How many valence electrons does chlorine have?
8 or 7.
7.
All right. Well then, take 7. I'll put it here. I'll give you guys. Note to self: don't put them in the refrigerator anymore.
Add stuff.
2, 3, 4, 5, 6, and 7.
We need one more.
One more. There you go.
Okay, no, we got it. We got it.
No,
I was gonna do this
Oh
one.
yeah.
No, we only need 7.
You wanna help me, George? Go ahead. This lesson smells really good.
What did the brown ones taste like?
Are there brown? I think they're purple.
Yeah, it's supposed to be that grape.
All right, so now we're gonna create an ionic bond between sodium and chlorine. We usually put the sodium in first. What's gonna happen between? So all these are electrons. What's gonna happen between the one electron of sodium? You can move it over. Now sodium's got a full level.
Boom.
And chlorine's got a full level. And the way that we illustrate this is like this. I'll do it on the board for you. When you draw this on your own paper, you're going to do it like this so that you can illustrate the movement. You're going to put your symbols. We'll do sodium, and it has my 1 valence electron. And then we'll do chlorine, which has my 7 valence electrons. And then what you do is you circle your 1 over here and you draw an arrow. You rewrite it as 1 plus, chlorine is 1 negative, equals NaCl. You see how these two charges balance each other out? You have a 1 positive and a 1 negative?
So you could draw that and then write the equation.
Because at some point, you're not going to have charges that balance each other out, and we'll go over that next. But when you have charges that balance each other out, that means you have 1 atom of sodium for each atom of chlorine. Compounds always occur in the same ratio. Anytime you have sodium chloride, you know you have 1 sodium atom and one sodium ion and 1 chlorine ion. It will never change. It will always be the same.
Did you make your own table somewhere?
Oh, wait. You have
some.
I guess. But you would have to do something to make the reaction occur. You know, like you'd have to add heat or something. I don't know exactly what
this one.
the reaction takes right now. When you're done writing that out, I want you to find magnesium and iodine.
Magnesium is Mg.
Yeah.
And iodine.
is I.
Oh, I have iodine.
I have
And I have magnesium.
Okay.
Bingo.
Bingo.
One.
Alright, I only have 1.
put our chlorines away. Chlorines right now. You might need to take out all the magnesiums and the iodines that you can find because you might need more than one.
I took them out.
I didn't have any.
We have one extra.
We have 2 extra ice.
We don't know if they're extra yet, do we?
Well, they're not extra.
All right, so we have magnesium, we have iodine. How many valence electrons does magnesium have?
2.
Because it's in group 2. So go ahead and find 2 red ones and do your Lewis structure. Boy. Yeah. That's actually how it goes there. It doesn't, I don't think it's that big of a deal. Now iodine. Where's iodine, Mason?
53 is in the.
What group is it?
7.
7. So 7 valence electrons. There's no blue, but you can use any color
We
you
use
want.
purple.
Sure.
Purple is like blue.
Or the one you actually thought was brown a minute ago. I'll start giving you some. You know what?
I have a different.
Sarah, when you're done taking that picture, can you bring me a paper plate from under the cabinet? It will be easier to fetch them if we have a paper plate.
Wait, how many does iodine have?
Look at the group.
7.
1 is fine.
Won't we need this other one because since there's 2,
I don't know.
Let's use
It
this
depends.
to form
We'll see.
Skittle.
you will have to.
We'll see. All right. So magnesium has 2 valence electrons and iodine needs 1. But magnesium needs to give away the 2 in order to be happy. So magnesium will give away 1,
And then 1 to the other one.
but is magnesium happy? Then iodine's happy, but the magnesium's not. So
Good.
you need another iodine. So the magnesium is very generous. It wants to give more stuff away.
He
But-
took it for the team.
So you need another iodine. You need to fill them in.
I get the purple one first. My 4, 5.
There's one here, so you just need one.
Here, how many? We did it.
All right, so the way that you write this one down is very similar. What happens here is we have magnesium that has 1, 2, plus iodine that's 1, 2, 3, 4, 5, 6, 7. Yeah. And then we write another plus over here, iodine. And then we draw our transfer. 1 comes over here, 1 comes down here. And then to write it as a formula. Now, this is where you can start learning how to do this without the Skittles. You see how you write your elements and you write their oxidation numbers next to them. The trick is you take the oxidation number and it's almost like cross multiplication. It actually goes here. And this one goes here. So Mg is going to get a 1 negative, or a 1. Do I need to write the 1? No. Iodine is going to get 2. So I write the 2 here. And now that's my compound, magnesium iodide. It means I have 1 ion of magnesium and 2 of iodine in every molecule of this compound. Okay? And now, what I'm going to do is I am going to show you covalent bonds. So you can do the rest of them later you can do them with Skittles or you can do them with just